All right, welcome back. We're here now on 8.3. We're going to be talking about adding and subtracting rational expressions. Remember last time in 8.2 we talked about multiplying and dividing. Now we're going to add or subtract. Remember with fractions, in order to add them together or subtract, you are going to have a common denominator. The bottoms are going to have to be the same. And then you just simply add or subtract the tops. As we see here, 1/5 plus 3/5, add the tops, that's 4/5. Very easy. 6/7 minus 4/7, well, subtract 6 minus 4, that's 2/7. Yeah, that's kind of nice, easy to remember. All right, so let's go into rational expressions and show you how that works. Once again, we have a common denominator, the same bottom. So what we do is we just keep that bottom the same, x plus 4, and then we add the tops. X plus x is 2x, and -3 plus -2 is -5. Easy peasy, lemon squeezy. That's as easy as it gets right there. All right, let's try another one of those, okay? Again, we have a common denominator. Well, this time, the denominator that's the same is x squared plus 1, so we just keep that. And now, subtraction this time. 3x minus 6x is -3x. -4 minus 1 is -5. All right, not too terribly difficult. We can do those. Obviously, be careful, especially with those negatives. Easy to make mistakes there. So now the question is, well, what if the denominators are not the same? What if the bottoms are different, right? Well, remember what we did is we said, all right, let's say an example of 2/6 and 3/10, and those are clearly not the same. So what we do is we find the denominator, a common denominator that they both can divide into. Well, the smallest number that 6 and 10 both divide into are 30. Well, okay, to make the 6 into a 30, we got to multiply it by 5. But remember, to convert that, we have to multiply the top by 5. 2 times 5 is 10. To get the 10 to be a 30, we got to multiply it by 3. So multiply its top by 3. 3 times 3 is 9. All we've done is change what the value of the fraction is, not the actual value of it. It's still the same thing. And then now we can add those together. And that's what we're going to do with rational expressions. So here we go. Let's try one of those. All right, so this case, we can see here that the bottoms, the denominators, are clearly not the same. So what we're going to do is, good idea is to factor this. And chances are, I'm just saying, is that one of the factors probably is going to be this one over here. Let's see if that's the case. Well, let's see. If I go x and x, two numbers that multiply to -4 but add to 3 would be +4 and -1. So what we notice here is that this and this are the same. That's a good thing. Makes it a little easier. So what we're going to do is we're going to change the denominator. This one's going to stay the same. We're going to have an x plus 4 times an x minus 1. And since I didn't change anything on the bottom, I don't change anything on the top. All right, now over here on the second fraction, yeah, we still have that x plus 4, but to make it look like this one, we have to give it an x minus 1 over here. Well, like we said before, if we change the bottom by multiplying by that, we better do the same thing to the top. So here we're going to take 2x times x and get 2x squared. 2x times -1 is -2x. Well, now we just keep the bottom the same, x plus 4 and x minus 1. Just leave it factored, that's fine. And then we're just going to add the tops. Well, we get a 2x squared. X and -2x is -x, and -3. And there we go, that's our final answer. Okay, so not too bad. Let's try another one of those. Again, converting, that's about as tough as it gets there, where we have to change one or both of the denominators to make it work. I think what I have set up for us is that we're only going to have to change one. All right, so here we go again, another situation where we can see that, again, the denominators are not the same. So we factor this one, and as we kind of guessed, this would factor into x plus 2 and x minus 2. So that becomes our common denominator, x plus 2, x minus 2. Now, on the bottom here, we did have the x plus 2, but we put the x minus 2 down there as well, so that means I have to multiply the top by that, giving me an x squared minus 2x. Over here, we didn't change anything, so don't change the top. All right, and now we have that common denominator of x plus 2, x minus 2, and now we can simply just add those, x squared minus 2x minus 8, and we can just leave it just like that. Okay, so that is simplifying with adding and subtracting fractions. A lot easier when the denominators are the same, that is for sure. All right, last thing we're going to talk about today are complex fractions. Fractions are bad enough. You know, we know that 5 out of every 4 people are bad with fractions. But anyway, we can even make them worse by having a fraction over a fraction. Crazy kooky, look at that. All right, there's going to be a couple ways that we're going to solve these. Again, is this. Now remember, we talked about this before, is that when we divide, which is really what a fraction is, we can instead multiply by its reciprocal. So a case like this, we have the x plus 2 over the x minus 1. Well, now, instead of dividing, that's really what that line means, is divide. We're going to multiply by the reciprocal. So we're going to flippy, x plus 5, x minus 3. Now, we're hoping that we maybe get some factors that would cancel from top to bottom, but nothing cancels. So that actually is your final answer. If nothing simplifies, nothing cancels. All right, let's look at one where it does cancel. This one, next one should have something that cancels here. Let's see what we got. I think we got another one here. Yeah, last one. All right, now this one. Ooh, okay. So we set this up, 20 over x minus 1. Now, instead of dividing by this, we're going to multiply by the reciprocal. So now the 6 goes on the bottom. And I'm going to be doing two things at once here. I'm going to put this at the top, but I'm also going to factor. And I'm going to take a 3 out of there and factor that into 3 times x minus 1. Now, look what happens here. We look for things to cancel. Anything from top to bottom. Look at the x minus 1. Chunga, chunga! Ooh, look at that. We multiply the tops. 20 times 3 is 60. 60 over 6 is just 10. Look at that crazy kooky. That thing right there simplifies to 10. Can you believe it? Crazy kooky. I love it. All right. Have some fun with this, with the fractions. Again, simplifying, adding, subtracting, and then simplifying these complex fractions. Again, we'll have the worksheet 8.3. Check your work and make sure to let me know if you have any questions. Till next time, I'm Mr. Boone.